Hey, good afternoon. How are we doing today? So today I'm looking at micropipettes. This is a standard micropipette. This is actually a pipetman micropipette. It's very similar to many of the pipettes you've probably seen in a chemistry or biochemistry laboratory. And I'm going to demonstrate its use today. And so first of all, not every micropipette is identical. You'll notice this one has a little blue tip. This one over here has a little yellow or gold tip, right? Or I guess it's got a different color because the tip is different. So the blue tip, or the blue color, is 100 to 1,000 microliters, and that uses kind of this larger pipette tip right here. Many of these are also blue in color. You'll notice this is actually in a blue container. So that's the blue. And then the yellow one, this is a little gold or yellow pipette tip, right? So the gold will not, this gold one will not fit the blue pipette tips, and the blue one is too big for the yellow pipette tips, right? So first of all, you want to make sure you get the right pipette tips that you can use. Now when you look at the pipette, this is the aspirating end over here. So that's where you take fluid in, you eject fluid out, you expel it out. You also have a couple things over on the business end over here. You have a pipette ejector button. You also have this large plunger kind of goes in, and that's what you use to aspirate, right? And then of course where it says pull, you can pull this out and adjust the actual volume, right? And so you can kind of adjust that to make sure that you don't go above 1,000 microliters, and make sure you don't go below 100 microliters in this case as well, right? So when you're dispensing, first of all, I want to adjust this. I'm going to just put on here exactly 1,000 microliters. So I got one right there. And then I'm just going to dispense H2O. In this case, it's deionized, or H2O right here. And so how do I do that? So what I'm going to do, first of all, when we look at our pipette end over here, you'll notice this plunger goes part way, but it kind of stops and it doesn't go all the way. It will go all the way, but there's kind of a pressure point right here, right? So when you're going to start, you're going to push this down to that pressure point. You're not going to go all the way. And then you're going to put your pipette tip in your fluid, and then you're going to release the plunger, and you're going to suck up all your liquid right inside of it. Now when you're going to dispense, you put in whatever container you will dispense in, and this is where you take the pipette and release all the way. Now you'll notice I went to the first pressure point, and there's a little bit of fluid at the end. The fluid there is called the blowout volume, so then you go all the way and eject everything, right? So that's when you're ejecting into your sample, you're going to eject all of your fluid. So you're going to start, you're going to go down to the first pressure point, put it into the fluid, suck it up, take it out, get ready to inject. You're going to inject it, and this is where you go all the way, right? So that's how we do that. Now this is exactly 1,000 microliters. They are fairly sensitive instruments. They usually don't need to be calibrated. But if you'd like to calibrate this, how can we calibrate this? Well, we can actually use the density of water, right? Because especially if we have pure water, deionized water, well, in this case, we can use the density of water, 1 gram per milliliter, to calibrate our pipette. And so if 1 milliliter of water has a mass of 1 gram, we can use an analytical balance to determine the mass of 1 milliliter or 1,000 microliters of H2O, pure H2O, deionized, and it should have a mass of exactly 1 gram, right? And so that's where I can use my analytical balance, right? So we can just kind of weigh that out. We just need a weighing boat. So we have a weighing boat right here. I can put this, there we go. Just put that right on here. Push that back. Now the first thing we need to zero our balance, because obviously if I've got a weighing boat on here, I need to neutralize and zero that out. So I've got exactly 0 grams now. Now I can weigh my water. And so this is where, let me adjust my camera a little bit, and then we'll determine the mass of our H2O. So I'm starting off with a tiered balance, 0.00 grams of H2O. And I'm going to start off with taking up exactly 1,000 microliters. We're going to open this up, and I'm going to inject right in my balance. Remember the blowout volume. And then we'll close this. So this says 0.954 grams. Now what I usually tell my students in the lab, we like to record all of our data, but when we're taking data, instead of writing things down, I usually just go ahead and take a photo of the first data point. Now, I do want to take an average and calculate a standard deviation here. We're going to record 2 more values. So I'm going to zero this again, back to 0.000. We'll take 1 more measurement. There's another one. We'll inject. Make sure I get my blowout volume. Push this in. And now I have 0.973 grams. I'll just take another photo of that. And now I zero this out again. And there we go, there's my final measurement. And it looks like 0.975 grams. There's my 3 measurements right there. And so now we're going to look at that. Obviously, we're not exactly 1 gram. We're a little bit less. So looks like we're kind of consistently off by maybe about 3% or so. But let's take a look at that and let's see how that works. Let's analyze that using Microsoft Excel, right? Okay, so let's do the math on calculating our standard deviation, and let's look at our statistics on our measurements. So the equation for standard deviation right here, is sigma squared equals the sum of xi minus x bar squared divided by n minus 1. So what is all that? Sigma is our standard deviation. The large sigma means take the sum of everything in here. So xi is just each observation. X bar is our arithmetic mean. And n is the total number of observations we have, in this case 3, right? So we can calculate this in Excel, and we're going to go ahead, and I've got my data in Excel right here. I've got 0.954, 0.974, and 0.975. Now if I want to calculate the average, I'm just going to take in A6, I'll do equals average, and then highlight these numbers here. and I get 0.967667. Now, in our equation, we need to take each number minus the mean, or minus the average. So in B, I'm going to take A2 minus A6. What you notice is the A2 is highlighted in blue, A6 is highlighted in red, right? And then I'm going to do the same for the other numbers. There we go. And so now I have xi minus x, right? Now just as a check, if I add these three numbers, these should add up to 0. And well, it doesn't look like that, but let's just check. Minus 1.11022 times 10 to the minus 16th power. Well, I'm going to call that 0, right? So that's pretty much close enough. Now, according to our equation, we need to take the square of that, right? And so in the next column, here's where I'm going to square it. Now, how do we square something? If I take, x sub I minus the average, the caret in Excel is a square function, right? So what I'm going to do is equals B2 squared. There's my square of the first one, equals B3 squared, and then equals B4 squared, right? So now I've got x sub I minus x bar all squared, right? Now what I'm going to do is I'm going to take the average, well, actually, remember our equation. So I've got this squared, and then I divide by n minus 1, right? So we're going to take, I'm going to put a couple of things in parentheses. I need to take the sum of all these numbers because that's summed. Right now, I've got two. I've got the first set of parentheses here and then the second set, because then I want to do divided by n minus 1 is 2, right? See, because I've got 3. 3 is n, and n minus 1 is 2, right? And so this is my this is my sigma squared, right? So I've solved everything up to here, but then I need to get the standard deviation. I need to take the square root of that, right? So I need the square root of this number, right? So let's just put in here equals square root of C6, and that is 0.011846. I can just round that off to 0.012 to 2 significant figures, and that is my standard deviation. So essentially, each one of these values is plus or minus 0.1012, right? Now I can express that as, for example, let's just say 0.954, and where's my plus or minus? I'm going to do plus or minus 0.012, right? So that's how I would write with the standard deviation. And of course, then the other numbers I can express 0.974 and 0.975. Here's the other one. So there are my three values, plus or minus 0.012. And so essentially what this tells me, of course, I should get 1, right? Because the density of water is 1 gram per milliliter. I'm pretty close to that within about 0.012 per 12 thousandths. So my actual values are a little bit outside of my standard deviation because, you know, I should get 1 exactly, and I'm a little bit lower than the standard deviation. So in this case, my pipette probably should be maintained a little bit. I probably need a little bit of maintenance on this because it's a little bit out, but it's still pretty close. It's still fairly accurate. Now, I showed you all that to be able to show you this. If I want to calculate the standard deviation, this is kind of nice because I can do all the equations and stuff. Well, in Excel, you can actually calculate the standard deviation a lot easier. And you just do equals STDEV. And you take the numbers you want the standard deviation of. Boom. There's my standard deviation. That matches exactly. So that's actually kind of nice. So again, there is more than one way to do things. This is, you know, 2 different ways to get a standard deviation. So there you go. So I hope you found this video useful, and go ahead and hit like and subscribe. And if you want to see, if you want to see more videos, it's very helpful to subscribe to the channel. And go ahead and, if you have any comments, leave the comments below. And I'm always looking for more questions and feedback about the videos. If you want to see something else that might be helpful, that would also be very good. So thank you for watching, and I will see you in the next video.